Hurricanes, also known as tropical cyclones, are among the most destructive natural phenomena on Earth. They have been responsible for countless tragedies, economic loss, and changes to human settlements in coastal areas. Yet, despite the destruction they can bring, hurricanes are natural systems with a critical role in the global climate. To fully grasp the science behind hurricanes, it's essential to explore their formation, structure, classifications, impact on the environment and society, and the strategies used to predict and mitigate their effects. What is a hurricane? A hurricane is a large storm system characterized by powerful winds and intense rainfall. It is a specific type of tropical cyclone, which is a broader category of storms originating in tropical and subtropical waters. A hurricane forms over warm ocean waters where specific atmospheric conditions foster the development of this type of storm. As the storm grows in intensity, it begins to rotate, gaining energy from the ocean's heat and moisture, eventually becoming a tightly organized system of clouds and thunderstorms that can span hundreds of miles. Tropical cyclones are generally classified by their intensity. The three main categories are tropical depression, the least severe type of tropical cyclone, with wind speeds of less than 39 miles per hour, 63 kilometers per hour. Tropical storm. This category includes systems with sustained wind speeds of 39 to 73 miles per hour, 63 to 118 kilometers per hour. Hurricane. Once wind speeds reach 74 miles per hour, 119 kilometers per hour, or more, a tropical cyclone is classified as a hurricane. These storms can be further divided into categories based on the Saffir-Simpson hurricane wind scale, ranging from Category 1, weakest, to Category 5, strongest. Formation of a hurricane. Hurricanes originate from disturbances in tropical regions, typically in areas where warm waters and specific atmospheric conditions come together. Several key factors must align for a hurricane to form. Warm ocean waters. The primary energy source for a hurricane is the heat from the ocean. Water temperatures need to be at least 80 degrees Fahrenheit, 27 degrees Celsius, to provide the necessary fuel for the system to develop. This is why hurricanes are most common in tropical and subtropical regions. Low wind shear. Wind shear refers to the difference in wind speeds or directions at various altitudes. Low wind shear is crucial because high wind shear can tear a developing cyclone apart before it has a chance to intensify, a pre-existing weather disturbance. Often, hurricanes begin as tropical waves or areas of low pressure. These disturbances provide the initial organizing center for a hurricane. Rotation, Coriolis effect. The Coriolis effect, caused by the rotation of the Earth, helps the storm begin to spin. This spinning motion is necessary for the development of a tropical cyclone. Structure of a hurricane. A hurricane is a highly organized system with several distinctive parts. The eye, the center of the hurricane, known as the eye, is an area of calm weather and clear skies. Despite its tranquil appearance, the eye is surrounded by the most violent part of the storm. The eye wall. Encircling the eye is the eye wall, a ring of thunderstorms that produce the hurricane's strongest winds and heaviest rains. The eye wall is responsible for much of the hurricane's destructive potential. Rain bands. These are long, spiraling bands of clouds and thunderstorms that extend outward from the center of the storm. Rain bands can bring heavy rain, strong winds, and even tornadoes. Classification of hurricanes. Hurricanes are classified using the Saffir-Simpson hurricane wind scale, which categorizes storms based on their sustained wind speeds and potential damage. Category 1, winds of 74 to 95 miles per hour, 119 to 153 kilometers per hour. Damage to homes and trees can be expected, and coastal flooding is possible. Category 2, winds of 96 to 110 miles per hour, 154 to 177 kilometers per hour. There is a greater risk of severe damage, particularly to roofs, windows, and trees. Category 3, winds of 111 to 129 miles per hour, 178 to 208 kilometers per hour. This is the point at which a hurricane is considered major. Devastating damage can occur, and electricity and water services may be disrupted for several days. Category 4, winds of 130 to 156 miles per hour, 209 to 251 kilometers per hour. Catastrophic damage to homes, infrastructure, and vegetation is possible. Category 5, winds exceeding 157 miles per hour, 252 kilometers per hour. This is the most destructive category, with total roof failure, extensive flooding, and widespread collapse of buildings expected. Impact of hurricanes. The effects of hurricanes can be devastating, and their impact can be felt both during and long after the storm has passed. Winds. The high winds of a hurricane can destroy buildings, knock down trees, and cause widespread power outages. Storm surge. One of the most dangerous aspects of a hurricane is the storm surge, which is the abnormal rise of seawater caused by the hurricane's winds pushing water toward the shore. This surge can inundate coastal areas, leading to severe flooding. In addition to storm surges, hurricanes bring heavy rains that can cause rivers to overflow, leading to inland flooding. This flooding can last for days or even weeks after the storm has passed. Tornadoes. Hurricanes can also spawn tornadoes, particularly in the outer rain bands. These tornadoes can cause additional damage beyond the hurricane's winds and rain. Environmental and economic effects. Hurricanes can reshape landscapes by eroding beaches, flooding wetlands, and uprooting forests. The loss of vegetation can lead to further erosion, which can affect ecosystems for years. Economically, the damage caused by hurricanes can be immense. The destruction of homes, businesses, and infrastructure can take years to rebuild, and the financial cost often runs into the billions of dollars. Hurricane prediction and mitigation. Advancements in meteorology have made it possible to predict hurricanes with increasing accuracy. Modern satellites, aircraft reconnaissance, and computer models allow scientists to track the development of tropical systems and estimate their future path and intensity. However, predicting the precise impact of a hurricane remains challenging. While meteorologists can often determine the general area that a hurricane will strike, predicting its exact path, intensity at landfall, and the size of the storm surge remains an inexact science. Hurricanes are powerful natural systems that have the potential to cause widespread destruction. Understanding how they form, their structure, and the risks they pose is critical for mitigating their effects. With continued advances in technology and forecasting, society can better prepare for and respond to these storms, reducing their impact on human life and property. However, as global temperatures rise and sea levels continue to increase, the challenge of dealing with hurricanes is likely to grow in the future, making it more important than ever to focus on disaster preparedness and resilience. Thank you for watching this video on what is a hurricane. Please view our other information videos and don't forget to like and subscribe to the channel. Have a great day.